I'm very happy to have the chance to be here today to share a little bit about a project that we worked on with the TxDOT Fort Worth District a few years ago. And this topic came up as part of the 100th anniversary celebration this year. And I think it ties in well with the first presentation that Greg Freeby gave. So hopefully he answered a lot of your questions about these older bridges, and I'll give you a little bit of an idea of a portion of the study that we conducted. And this was done with my colleagues at Texas A&M and TTI, including Stefan Hurlebaus and Yvonne Diamjanovich, who are both faculty in civil engineering, along with Eric Pulls, who was a master's student, and a couple other graduate students that helped us out as well. I also want to acknowledge all the TxDOT personnel who were involved in the project, especially the group in the Fort Worth district. It was really great to work with them, and hopefully they felt the same, although many people retired during and after the project, so I'm not sure if they shared the same good experience. But Maribel Chavez was very much a champion for this effort. And actually I heard Ralph Brown's name earlier, and he helped to get TTI involved in this work. And many others are listed here. Fred Valles was the project manager. I'll give you some motivation and objectives for the project, and then we'll talk about a little bit of background to help get us oriented. And then we'll focus on the research tasks that focused on the framework for prioritization of the historic bridges in the Fort Worth and Tarrant County area. And then I'll try to just give you a quick summary of the top 10 bridges and a few conclusions and takeaways. So in terms of motivation and objectives, we come back to the West 7th Street Bridge, which you saw earlier had been replaced by a very nice signature bridge recently. And this is the original bridge that was identified for removal in 2011. This led to some concern by the historic interests in the community that they were losing a very important structure that was part of the city and the look and feel of the area. And so there was some resistance at the community level. You know, why are we losing a bridge that's one of the few bridges of this age in the community? And so there was some discussions. TTI was actually brought in kind of as a third party to some of those discussions between TxDOT, the city of Fort Worth, and the historic bridge group, or historic community group, to discuss why this bridge was being removed, and it had to do with issues with the materials and deterioration. I think everybody would agree that Fort Worth came out very well in the end with the replacement bridge, and I think everyone's quite happy. I was able to see that structure recently, and it turned out really well. But this did lead to an opportunity. TxDOT decided to have a project to focus on what can we do to be more proactive so that we aren't losing some of the historic infrastructure of the city and county in this area. As we know, there's a lot of benefits of historic bridges. Among those is that they're part of the history of the community, whether there were historic events or people from history at those locations. A lot of people remember those structures. They also provide aesthetic value and beautify the community, especially the ones that are those signature structures. And they also bring commercial value and functionality to the area. But the challenge remains that these older structures do deteriorate, and we know that funding is limited not only for replacing bridges, but even maybe more so for rehabilitating bridges in some cases. And so that maintenance was becoming quite a drain on the city of Fort Worth, who owned the bridge. So the primary goal for this project was to look at how to preserve the integrity of historic bridges for future generations with better planning and management strategies, with the idea that hopefully we can maintain these bridges so that if they're identified and there's proactive preservation in place, then we won't have to replace so many of them. So just a little bit of background. I want to talk about a few parameters, some of the TxDOT studies and frameworks in other states. So the first thing that we'll look at here is the National Bridge Inventory Historical Significance Rating. This was one of the parameters that we used for prioritizing bridges. And we can see that these are related to the National Register of Historic Places. If there is a 1, that indicates that the bridge is on the National Register already. We can see that in Tarrant County, only 1 bridge was listed at the time we did the study. The report wrapped up in 2013, so fairly recently. 2 indicates that the bridge or structure is eligible for listing on the National Register, and there were 13 bridges in this category. A 3 is that it may be eligible or it may be on a state or local register. There were 14 bridges in the NBI listed as number 3. And then number 4 is eligibility is not determinable at the time. 151 bridges were listed as 4, and then 5 are not eligible. So the majority of the bridges that we looked at were not eligible, and as we can imagine, Fort Worth has grown a lot in recent years. And one of the criteria for the National Register is that the structure be at least 50 years old. So if we quickly look at National Register of Historic Places eligibility criteria, there are 4 criterion that might be used to get a structure onto the National Register. The one that we focused on in the quantitative rating system that we'll talk about later deals with criterion C, which is that it embodies distinctive characteristics of a type, period, method of construction, or represents the work of a master, whereas criterion A and B deal with the structure is associated with a historic event or a significant person in history. The sufficiency rating that is also reported for the National Bridge Inventory Database was also used. As you know, the sufficiency rating goes from a 0 to 100 score, and it's based on 3 different parameters. One is structural adequacy and safety, that provides the bulk of the rating. Serviceability and functional obsolescence contributes 30% to the rating, and essentiality for public use is at 15%. So if the rating is 80 to 100 composite score, it is considered to be in good condition. If it is 50 to 79.9, it is eligible for rehabilitation, and below that, it is eligible for replacement. So there are several TxDOT studies that have been going on in recent years that are important to this effort. One is the TxDOT Metal Truss Bridge Task Force study that looked at preservation options for 38 metal truss bridges. There's also a TxDOT inventory survey of non-truss structures done in the late 90s that looked at 40,000 bridges for National Register eligibility, and then a TxDOT evaluation of bridges built in 1945 to 1965, which was done in the 2004 to 2009 time period. It looked at over 14,000 bridges for National Register eligibility. All of these studies have been wrapped up into one report, which is available through the Environmental Affairs Division, and it's entitled Historic Road Infrastructure of Texas, 1866 to 1965. And I think you can find that online. We did look at different state DOT approaches to determining prioritization for historic bridges. Indiana DOT has this matrix that was developed in a study that was conducted for the entire state. And we can see that on the vertical axis, we have a condition score that's relatively high, medium, or low for the type of bridge in the state that they're looking at, whether it's a concrete bridge, metal truss, or whatever. Eligibility score, high, medium, low, based on the condition and other factors with respect to historic significance. Ohio DOT had a look at technological significance and general significance. Technological significance dealt with the length of the individual span and special features, whereas general significance dealt with history, integrity, and aesthetics. So just a little quick snapshot of some of the other frameworks done by other states. There's quite a bit of information out there on this. We decided to leverage some of the TxDOT work that had been done for our study. And as we move into the research tasks, I just wanted to give you an overview that this project dealt with not only the prioritization methodology that we developed and implemented for Tarrant County bridges, but we also looked at identifying potential funding sources for historic bridge preservation, performance-based bridge preservation in terms of providing guidance for individual bridge preservation based on element types and so on, and then also developing resource allocation methods that could help in deciding how to best spend money for an inventory of bridges that all have some level of priority and needs, but how do we decide how to spend limited resources? So the guidance for individual bridge preservation looked at condition assessment and structural health monitoring issues. We provided guidance as well for mitigation strategies. And then we provided a template for developing individual bridge preservation plans that's very flexible and would be a nice starting point for anyone who might be trying to look at kind of systematically for a particular bridge what the suggested preservation approach might be at each element level and for the entire structure. So those are all available, but we want to focus today on the prioritization that we did for Tarrant County, just because of limited time. And then at the end, I'll let you know how to get a hold of the other information. So the inventory review and prioritization was conducted for all Tarrant County bridges. We started with 2,860 in the database and went through an initial screening process. That initial screening was to remove all bridges built after 1972. So back in 2012, we decided that while 50 years is the cutoff for the National Register, we would go with 40 years old and older so that we can have some results that are useful for maybe the next 10 years or so. We also removed culverts because we considered those to maybe be not as essential to the study and discussions with TxDOT. We removed railroad bridges. They are not typically owned by TxDOT or the city. And then any bridges that did not have sufficient information in the NBI for sufficiency or historical significance were removed, leaving from 2,427 bridges eliminated, we had 433 remaining. So we went through a fairly simple filter initially with those 433 bridges, and we looked at historical significance as well as sufficiency rating. And basically we have the 1 through 5 on historical significance versus the sufficiency rating. And we went ahead and made our cuts based on eligibility for rehabilitation, which is the 50 to 79.9. So we just divided that range evenly. And then from 0 to 49.9, we have eligibility for replacement, and those are divided evenly as well. And then of course 80 to 100 indicated good condition. And then we decided that if it is at a historical significance of 4 or 5, that would have the lowest priority, so we gave that a priority 3. And then we divided the remaining cells here based on the higher historical significance in conjunction with a reasonable sufficiency rating. And so this is how it worked out, priority 1, 2, and 3. We went ahead and applied the matrix approach to the remaining bridges, and we end up with 404 bridges down in the red zone. And only one bridge, like I mentioned before, actually had a historical significance of 1. So we have just a few here in the green category and a few, 29 total in both categories. So we decided at this point, TxDOT was interested in having more of a ranking of the bridges, and we felt like what we had done so far was a good initial filter, but we wanted to do a little bit more review. We were driving around Fort Worth and we were seeing some bridges that were not on the list, and we weren't quite sure why they weren't showing up. So it goes to show that maybe sometimes the NBI entries are not always complete, maybe especially for historical significance. And so sometimes those are in the process of being updated. The district has sent information maybe to the Environmental Affairs Division, but there's a process of reviewing that to update it. So we went ahead and we looked at all pre-1940 bridges because we wanted to at least capture all bridges in that time period from 1940 and earlier. And we went ahead and added 8 of those bridges that came up from that third priority region into our list. And so we ended up with a total of 37 bridges that we reviewed. We decided to do a better, more fine resolution rating system. And this was really patterned after some of the earlier TxDOT studies, looking at different measures of historical and engineering significance for these bridges. And so one of the methods that we reviewed in the earlier TxDOT study for pre-1950 bridges was to do a certain number of points, in this case 40 points maximum for the year built. The main span length could earn up to 20 points. Overall length could add another 4 points. The rail type was given 14 points. Special design up to 10 points. Structural integrity, meaning that the original structure is still there in good condition, hasn't been modified. Site integrity, in terms of the integrity of the site with respect to historical significance. And then sufficiency rating also enters in, but at a lower level. Just 8 points for that. So we have a total of 112 that can be earned for each bridge. And then I want to give you just a little bit of information about a few of those categories and how they were broken down. If we were looking at a bridge that was built between 1900 to 1909, it could get the full 40 points. And then for each decade, we reduced by 5 points until we hit post-1959, and that can earn up to 10 points for a bridge that's at least 40 years old. In terms of main span length, some of the considerations were the type of bridge, and so each individual type would have its own main span length that would be considered to be a technological advancement for that bridge type when it was first being constructed. And if we look at the points, there's a maximum of 20 available, and for the concrete girder bridge, that means that if you have a 45-foot span or greater, you get the full 20, which we know is not a huge span these days, but at one time that was significant. And so if we look at how was this decided, we were following the earlier TxDOT study that looked at the statewide inventory, and for concrete girder bridges, the top 5% of the spans for that type of bridge would be in that 20-point category. So if we go down to the 10%, top 10%, that would be 40 to 45-foot spans. And similarly for concrete slab bridges, 30 feet and higher would be given full points, and 65 feet for steel I-beams. We had to adapt this to some of the other bridge types that are being used in Fort Worth: concrete arch bridges, plate girder bridges, rigid frames, and trusses. So similarly, we also divided out the points based on what we were seeing in the inventory. The overall length, as I mentioned, does add a little bit to the total rating. And so, for example, a concrete girder bridge with more than 420 feet would be given up to 4 points. 100 to 420 feet would be given 2. So I'm just going to kind of skip through these. The rail type is, again, based on the decorative nature of the rail, the historic nature of the rail. We could earn up to 14 points for types A through J, special design 12, and types K and L would have 10, and then we have a few other types at lower points. Special design, whether it's decorative elements, which would get the highest number of points like we see in this open spandrel arch system. Engineering response, we give an example of the 8-point category. Super and substructure, both having special design elements, would get up to 6. And so finally, that final inventory of 37 bridges, we ended up with scores from 40 to 104. Again, all these that were TxDOT recommended at the beginning, the ones that they expected to see on the list did show up there, except for some of the railroad bridges that they had initially identified. And we can see the scatter in the, here's the main Fort Worth area and into Tarrant County where those bridges are located. And I just want to quickly, if we have a few seconds, I can just quickly scroll through the top 10 bridges. Some of these probably would not be too much of a surprise to you if you're in the area, especially the Paddock Viaduct, BU 287P North Main Street over Trinity River, built in 1914, is the bridge on the National Register of Historic Places, and it had a overall score of 106. We can see where it appeared in our matrix over here. Again, this one did have some issues recently with sufficiency rating, but it was upgraded, bringing it up to a 66. The next one is Samuels Avenue over West Fork Trinity River, built in 1914 with a concrete girder system. West Lancaster over Clear Fork Trinity River is a steel truss bridge, and it is owned by City of Fort Worth, built in 1938. And a number of these bridges you can see almost next to each other if you go walking along the West Fork of the Trinity River, or the Clear Fork is in that area too. Some of these are a little bit more, I think, off the beaten path, but we see an example of a concrete girder bridge with a H-type rail built in 1928 with some decorative elements over Sycamore Creek on State Highway 180. This was an interesting bridge. We had to go through a bar in order to get underneath to see the structure. So some of you may want to go on a field trip up there. I don't know. This is East Exchange Avenue over Marine Creek, and they actually have a building on top of the bridge and a street. So it's a very interesting structure from that point of view, and it's also a closed spandrel arch down in the stockyard area, I guess. And number 6 was East Vickery Boulevard over Sycamore Creek, built in 1930, an arch bridge with a type H rail. And then we have number 7, State Highway 199, Henderson Street, another concrete arch open spandrel built in 1930, a little bit newer structure. And State Highway Henderson 199, West Fork Trinity River, again another concrete girder with a variable depth T. And then number 9 is a bridge built in 1938 over Sycamore Creek. It's a concrete girder T-beam. And then number 10, US 377 East Belknap over the Trinity River, built in 1932 with a concrete girder variable depth T-beam system. So just real quickly, a few conclusions and takeaways. What we learned from this process is that the historical significance and sufficiency ratings are a good start to sorting out the bridge inventory, but they're not adequate to give a more accurate prioritization of the bridges. So the quantitative rating system that was developed on some earlier TxDOT work seemed to provide a good detailed assessment relative to other Texas bridges. We also found that past preservation programs are useful as models, such as the Indiana DOT. We kind of patterned that initial matrix after some of their work. But we often need to modify because of the specifics of the bridge inventory. And finally, I just wanted to note that the prioritization framework that was developed in this study could be easily applied to other inventories, especially those in Texas. If you're interested in that, I'd be happy to talk with you more. We do have a report that describes all these additional research tasks. So if you're interested, you can go to the TTI website and download this report. You can just search on my last name and it should come up. This was, again, supported by the TxDOT Fort Worth office in response initially to the concerns with the historic group. I'm happy to say that after the end of the project, and we did have a lot of community engagement, which was very important, Historic Fort Worth actually gave an award to this project. So they're very happy with the results and to see a more proactive approach being taken to reviewing the bridges in the community that are considered to be historic.